As we enter the distillery, you'll be amazed by its sheer size. This facility produces millions of liters of whiskey annually, enough to fill Olympic-sized swimming pools. The journey begins with grain selection, a crucial step that sets the foundation for flavor. Barley, corn, rye, and wheat are the primary grains used, each contributing unique characteristics to the final product. Next, we'll explore the malting process. Here, grains are steeped in water and allowed to germinate, activating enzymes essential for fermentation. Now that our grains have sprouted, it's time for them to take on a new form. Ever wondered why some whiskeys taste sweeter than others? The answer lies in a carefully controlled process that extracts sugars from grains. This stage sets the foundation for the whiskey's entire flavor journey. Welcome to the mashing process, where science meets culinary artistry. Here, the malted grains are ground into a coarse flour called grist. This grist is then mixed with hot water in large vessels known as mash tuns. The mixture of grist and water is called the mash. Temperature control is crucial during this stage. The water is typically heated to around 63 16.7°C. This specific temperature range activates enzymes in the malted grains, which break down the starches into fermentable sugars. It's a delicate balance. Too hot, and the enzymes are destroyed. Too cool, and they won't work efficiently. The mashing process usually takes about an hour. During this time, the mash is stirred continuously to ensure even heat distribution and maximize sugar extraction. The result is a sweet liquid called wort, which contains all the fermentable sugars that will eventually become alcohol. Different whiskey styles require different mash bills or grain recipes. For example, bourbon must contain at least 51% corn in its mash bill, while rye whiskey must have at least 51% rye. The remaining percentages can be made up of other grains like barley or wheat. These variations in mash bills contribute significantly to the final flavor profile of the whiskey. Let's take a closer look at how these mash bills affect flavor. Corn contributes sweetness and a full body to the whiskey. Rye adds spicy notes and a drier finish. Wheat brings a softer, smoother character, while malted barley provides nutty, toasty flavors. By adjusting the proportions of these grains, master distillers can create a wide range of flavor profiles. For instance, a high Rayab Bourbon might have a mash bill of 60% corn, 35% rye, and 5% malted barley. This would result in a whiskey with the sweetness of Bourbon but with a spicy kick from the rye. On the other hand, a wheated bourbon might replace the rye with wheat, creating a softer, more mellow whiskey. The mashing process doesn't just extract sugars, it also pulls out other compounds from the grains that contribute to flavor and mouthfeel. Proteins, for example, can affect the texture of the whiskey, while certain acids can influence its perceived sweetness or dryness. After the mashing process is complete, the sweet wort is separated from the spent grains. This is typically done through a process called lautering, where the liquid is drained from the mash tun through a series of screens or a false bottom. The spent grains, rich in protein and fiber, don't go to waste. They're often used as animal feed or in the production of other food products. The wort then moves on to the next stage of whiskey production. But before we get there, it's worth noting that some distilleries add a step called secondary mashing or decoction mashing. In this process, a portion of the mash is removed, boiled, and then returned to the main mash. This can help extract additional sugars and create more complex flavors. It's also interesting to note that the mashing process in whiskey production shares similarities with beer brewing. Both processes involve extracting sugars from grains to create a fermentable liquid. However, in whiskey production, the goal is to extract as much sugar as possible, as these sugars will be concentrated during distillation. As we move beyond the mashing stage, whiskey production enters a realm where microscopic organisms become the unsung heroes. What if I told you that the same tiny creatures responsible for making your bread rise are also essential in creating the complex flavors of your favorite whiskey? This surprising connection between baking and distilling lies at the heart of fermentation, the next crucial step in our whiskey-making journey. Fermentation is where the magic truly begins in whiskey production. It's a process that transforms the sweet wort we created during mashing into a low-alcohol liquid called wash. This transformation is made possible by our microscopic allies, yeast. These single-celled organisms consume the sugars in the wort, producing alcohol and carbon dioxide as byproducts. The choice of yeast strain is a critical decision for master distillers. Different strains can produce vastly different flavor profiles in the final product. Some yeasts might enhance fruity notes, while others could bring out more spicy or earthy characteristics. This is where the art of whiskey making truly shines, as distillers carefully select and cultivate their yeast strains to achieve the desired flavor profile. Let's take a closer look at the fermentation process. The wort is pumped into large vessels called washbacks or fermenters. These can be made of wood, stainless steel, or even concrete, depending on the distillery's traditions and preferences. The yeast is then added to the wort, and the fermentation begins. The fermentation process typically lasts between 48 to 96 hours, depending on various factors such as the type of whiskey being produced, the yeast strain used, and the desired flavor profile. During this time, the mixture bubbles and froths as the yeast works its magic, gradually converting sugars into alcohol. Temperature control is crucial during fermentation. Most distilleries maintain a temperature between 20 degrees and 35 degrees to ensure optimal yeast activity. Too cold, and the yeast becomes sluggish. Too hot, and it might produce unwanted flavors or even die off. As fermentation progresses, the liquid's sugar content decreases while its alcohol content increases. By the end of the process, the wash typically contains about 5 to 10% alcohol by volume. This might not seem like much, but remember, we're still far from the final product. Master distillers and their teams closely monitor the fermentation process. They regularly check the specific gravity of the liquid, which indicates how much sugar has been converted to alcohol. They also keep an eye and nose out for any off flavors or aromas that might indicate a problem with the fermentation. It's worth noting that fermentation isn't just about alcohol production. This stage is also crucial for developing many of the flavor compounds that will ultimately contribute to the whiskey's character. Esters, which give fruity notes, and phenols, responsible for smoky or medicinal flavors, are just a few examples of the complex chemicals produced during fermentation. Some distilleries have unique approaches to fermentation. For instance, some Scotch whiskey producers use wooden washbacks, believing that the bacteria living in the wood contribute positively to the whiskey's flavor. Others use longer fermentation times, sometimes up to a week, to develop more complex flavors. The size of the fermentation vessels can also impact the final product. Larger vessels tend to produce a more consistent product, while smaller ones can lead to more variation between batches. This is another factor that master distillers consider when designing their production process. Once fermentation is complete, the wash is ready for the next stage of whiskey production. But before we move on, it's important to appreciate the complexity of what we've just witnessed. In a matter of days, we've gone from a sweet liquid to a low alcohol wash, teeming with flavor compounds that will form the backbone of our whiskey. With fermentation complete, our wash holds the essence of whiskey, but it's not quite ready for the bottle. What if I told you that the next step involves an ancient technique that can transform this humble liquid into liquid gold? Let's explore the art and science of distillation, where heat and vapor work in harmony to create something extraordinary. Distillation is the heart of whiskey making, a process that concentrates the alcohol and flavor compounds we've carefully cultivated. This stage is where the wash, typically containing 5 to 10% alcohol by volume, is transformed into a potent spirit with an alcohol content of around 70%. The principle behind distillation is simple. Alcohol boils at a lower temperature than water. By heating the wash to a specific temperature, we can separate the alcohol from the water and other components. The alcohol turns into vapor, which is then cooled and condensed back into liquid form. In practice, however, distillation is a complex process that requires precise control and expert judgment. Most whiskey distilleries use one of two types of stills: pot stills or column stills. Pot stills, which resemble large copper kettles, are traditional and commonly used for batch distillation. Column stills, on the other hand, are more modern and allow for continuous distillation. Let's take a closer look at how a pot still operates. The wash is heated in the pot, causing the alcohol to vaporize. This vapor rises through the neck of the still and into a condenser, where it's cooled back into liquid form. This liquid, known as low wines, typically has an alcohol content of about 20–30%. But we're not done yet. The low wines are distilled again in a spirit still, further concentrating the alcohol and flavors. This is where the distiller's skill truly comes into play. The distillate that comes off the spirit still is divided into 3 parts: the heads, hearts, and tails. The heads, also known as foreshots, are the first vapors to come off the still. These contain volatile compounds like methanol and acetone, which are not only unpleasant to taste, but can be dangerous if consumed in large quantities. The distiller carefully separates these and discards them. Next comes the hearts, the purest and most desirable part of the distillery. This is what will eventually become whiskey. The distiller must use their experience and sensory skills to determine exactly when to start and stop collecting the hearts. Finally, we have the tails, which contain fusel oils and other less desirable compounds. While some of these can contribute to flavor in small amounts, too much can result in off flavors and aromas. The decision of where to make these cuts between heads, hearts, and tails is crucial. It significantly impacts the character of the final whiskey. Some distillers might choose to include a bit more of the tails for a fuller-bodied whiskey, while others might make a cleaner cut for a lighter spirit. Column stills, also known as continuous stills, operate on the same principle but allow for a more efficient and continuous process. The wash is fed into the top of the column and steam is injected from the bottom. As the wash cascades down through a series of perforated plates, it meets the rising steam. This repeated process of vaporization and condensation allows for a more precise separation of different components. The type of still used can have a significant impact on the final product. Pot stills tend to produce a heavier, more flavorful spirit, while column stills typically result in a lighter, cleaner spirit. Many distilleries use a combination of both types to achieve their desired flavor profile. It's worth noting that the material of the still also plays a role in the whiskey's character. Copper, for instance, is prized for its ability to remove sulfur compounds, resulting in a smoother spirit. Some distilleries even have unique still shapes that they believe contribute to their whiskey's distinct flavor. The number of distillations can also vary. While most whiskeys are distilled twice, some, like Irish whiskey, are often triple distilled for an even smoother result. Each distillation further refines and concentrates the spirit. Temperature control during distillation is crucial. Too high a temperature can cause the still to puke, sending unwanted compounds into the distillate. Too low, and the process becomes inefficient. Master distillers must carefully monitor and adjust the temperature throughout the process. With the distillation complete, we're left with a clear, potent spirit, but it's far from the rich, amber whiskey we know. What turns this raw alcohol into a complex, flavorful drink? The answer lies in an aging process that's part science, part alchemy, where wood and time work in harmony to create something truly extraordinary. Aging is a crucial step in whiskey production, responsible for developing the spirit's color, aroma, and much of its flavor. This process takes place in wooden barrels, typically made from oak. The choice of barrel is critical, as it significantly influences the final product's character. Most whiskey producers use either American white oak or European oak barrels. American oak tends to impart sweeter flavors like vanilla and caramel, while European oak often contributes spicier notes. The previous use of the barrel also plays a role. For instance, bourbon must be aged in new, charred oak barrels, while Scotch whiskey often uses barrels that previously held bourbon or sherry. During aging, several chemical reactions occur within the barrel. As temperatures fluctuate, the whiskey expands and contracts, moving in and out of the wood. This process extracts compounds from the wood, including lignin, which breaks down into vanillin, giving whiskey its characteristic vanilla notes. Oxidation is another key process during aging. Small amounts of oxygen seep through the barrel, interacting with the whiskey and softening harsh flavors. This interaction also contributes to the development of fruity and nutty notes over time. The environment where the whiskey ages significantly impacts its development. Factors like temperature, humidity, and air pressure all play a role. In Scotland, for example, the cool, damp climate results in a slower aging process compared to warmer regions like Kentucky. This difference in climate is one reason why Scotch whiskey often ages for longer periods than bourbon. As whiskey ages, it also loses volume due to evaporation. This loss, known as the angel's share, can amount to about 2% of the barrel's volume each year. While this might seem like a waste, it's actually a crucial part of the concentration and flavor development process. The length of aging varies depending on the type of whiskey and the desired flavor profile. Some whiskeys are aged for just a few years, while others may spend decades in the barrel. Generally, the longer a whiskey ages, the more complex its flavor becomes. However, there's a point of diminishing returns, and over-aging can result in a whiskey that's too woody or tannic. Master distillers carefully monitor the aging process, regularly sampling barrels to determine when the whiskey has reached its peak. This requires a skilled palate and years of experience to recognize when a whiskey has achieved the perfect balance of flavors. Interestingly, the location within the warehouse where a barrel is stored can also affect the aging process. Barrels stored on higher floors, where temperatures fluctuate more dramatically, often age faster than those on lower floors. Some distilleries rotate their barrels to ensure more consistent aging across their stock. While aging is crucial for most whiskeys, it's worth noting that not all spirits require extensive aging. White whiskeys or moonshines are unaged or minimally aged, offering a different flavor profile that some enthusiasts appreciate for its raw, grain-forward character. The aging process also contributes to the whiskey's color. As the spirit interacts with the wood, it extracts tannins and other compounds that give it its characteristic amber hue. The longer a whiskey ages, the darker it typically becomes. However, it's important to note that color alone isn't always an indicator of quality or age, as some producers use caramel coloring to achieve a consistent appearance. Now that we've seen how whiskey gains its color and complexity, let's uncover the final crucial steps. Did you know that a single person's palate can influence millions of bottles? The role of the master blender is key to ensuring every sip tastes just right. Blending is where science meets art in whiskey production. Master blenders are the unsung heroes of the whiskey world, responsible for maintaining consistent flavor profiles across thousands of bottles. Their job is to combine different barrels of aged whiskey to create a harmonious final product that matches the distillery's signature taste. The blending process begins with careful sampling of individual barrels. Master blenders use their highly trained palates to assess the characteristics of each whiskey, noting flavors, aromas, and mouthfeel. They then combine these samples in various proportions, seeking the perfect balance that will recreate the desired flavor profile. This process is both an art and a science. While master blenders rely heavily on their sensory skills, they also use analytical tools to measure factors like alcohol content, color, and chemical composition. This combination of subjective tasting and objective measurement helps ensure consistency from batch to batch. Once the master blender has determined the ideal combination, the selected barrels are mixed in large vats. This is where another crucial step occurs: cutting the whiskey with water to achieve the desired alcohol content. Most whiskeys are bottled at between 40% and 50% alcohol by volume, though some premium expressions may be higher. The addition of water is more than just dilution. It actually helps to open up the flavors of the whiskey, making it more approachable and revealing subtle notes that might be masked by the high alcohol content. The type of water used is crucial, with many distilleries priding themselves on their pure water sources. Following blending and proofing, the whiskey moves to the bottling line. Modern bottling facilities are highly automated, capable of filling thousands of bottles per hour. However, quality control remains a critical part of the process. Samples are regularly taken from the bottling line and subjected to both sensory and chemical analysis to ensure they meet the distillery standards. The bottling process itself involves several steps. Bottles are first cleaned and sterilized, then filled with a precise amount of whiskey. They're then capped or corked, labeled, and packaged. Many distilleries have implemented sustainable practices in their packaging and distribution processes. For example, some use recycled glass for their bottles or eco-friendly packaging materials. Throughout the bottling process, strict measures are in place to maintain the whiskey's quality. The entire bottling area is kept at a constant temperature to prevent any changes to the whiskey's character. Air exposure is minimized to avoid oxidation, which could alter the flavor profile. Some whiskeys undergo a final step before bottling: chill filtration. This process involves cooling the whiskey to near freezing temperatures and then passing it through a fine filter. This removes certain compounds that can cause cloudiness when the whiskey is chilled or water is added. While chill filtration improves the whiskey's appearance, some argue that it can remove flavor compounds as well. As a result, many premium whiskeys are now bottled without chill filtration, a fact often proudly stated on the label. For single malt or single barrel whiskeys, the process is slightly different. These whiskeys come from a single distillery, in the case of single malts, or a single barrel, for single barrel expressions. They don't undergo the same blending process as blended whiskeys, but they still require the expertise of a master distiller to select the right barrels that exemplify the distillery's style. It's worth noting that the whiskey's journey doesn't end at the bottling plant. The way a whiskey is stored and transported can also affect its quality. Temperature fluctuations and exposure to direct sunlight can alter the whiskey's flavor over time. That's why proper storage conditions are crucial, both in the distribution process and in retail environments. Interestingly, some whiskey enthusiasts argue that a newly opened bottle of whiskey needs time to breathe before it reaches its peak flavor. This is because the whiskey has been sealed in an airtight environment for months or years, and exposure to air can help open up its flavors. While this is a matter of personal preference, it shows how the whiskey experience extends beyond the distillery and into the hands of the consumer. As we've seen, whiskey production is a complex journey from grain to glass, involving carefully controlled processes and the expertise of skilled craftsmen. From the selection of grains to the final bottling, each step contributes to the unique character of the finished product. Understanding this process can greatly enhance your appreciation of whiskey, allowing you to discern the subtle differences between various styles and brands. Next time you select a whiskey, consider its journey. Think about the grains used, the type of still, the aging process, and the skill of the master blender. When you taste it, try to identify the flavors imparted by each stage of production. You might discover a new depth to your favorite dram. The world of whiskey making beautifully blends age-old traditions with modern innovations, resulting in a spirit that continues to captivate drinkers worldwide.